Hello and welcome to lesson 5H. I can identify the properties of a square and prove that a quadrilateral is a square. Okay, a square is a quadrilateral that has four congruent sides and four congruent angles. This makes it the regular quadrilateral because it's both equiangular and equilateral. Quadrilateral. Therefore, we say a square is not just a quadrilateral, it's also a parallelogram, a rhombus, and a rectangle. It has all of the properties of these three things. It's equiangular, and it's equilateral. Meaning it's the regular quadrilateral. So if we were to mark up all the things we know about a square, life gets pretty complicated pretty quickly. I'm going to go ahead and draw my diagonals. Well, we know that that all four sides are congruent. My opposite sides are parallel because it's a parallelogram, right? My angles are all right angles. I'm just going to mark those two because it's a rectangle. I know that my diagonals are perpendicular because it's a rhombus. My diagonals are all congruent because it's a rectangle. And I know that my diagonals bisect the opposite sides. I'll do that in a different color because it's a rhombus. And I know that all four angles are congruent because it's a rectangle. So it's got tons of stuff going on. Well, squares are awesome because everything is true, but squares are also not awesome because everything is true. Because in order to prove that a shape is a square, I have to prove that it is a parallelogram, a rhombus, and a rectangle. That means you're going to have three parts to your proof before you can get down and say that something is a square. So I prove that it's a parallelogram by using any of the 6 methods we learned before. I can show that both pairs of opposite sides are parallel. I can show both pairs of opposite sides are congruent. I can show that an angle of a quadrilateral is supplementary to both of its consecutive angles. I can show that pairs of opposite angles are congruent. I can show that the diagonals bisect each other. Or I can show that one pair of opposite sides is both parallel and congruent. So I do all of that to prove it's a parallelogram. Then I got to prove it's a rhombus. I can prove some things are rhombus by using the definition and show that all four sides are in fact congruent. Or I can show that diagonals of the parallelogram are perpendicular, or I can show that one diagonal bisects a pair of opposite angles. Then once I've proven something to be a rhombus, I now have to prove it to be a rectangle. I can do that by the definition to show that all four right angles are congruent angles, or I can show that the diagonals are congruent. So I've got two options there. Then once I've done that, I will have proven the quadrilateral to be a parallelogram, a rhombus, and a rectangle. And once I have proven all of that rectangle, then I have shown that this thing is a square. So proofs for squares are not pretty because they have to be done in 3 sections. But let's take a look at just quickly identifying and classifying these quadrilaterals and deciding if they're actually squares. So here I know we've got a parallelogram because I've got my opposite sides are parallel, and I've got 4 congruent sides, so at the very least it's a rhombus, but I have nothing to show that this thing is a square. I have nothing to show it's a rectangle. So the best I can label him as a rhombus. He can't go any further than that. This guy, I've got a pair of opposite sides parallel and a pair of opposite sides congruent, but they're not the same opposite side, so I can't even prove it to be a parallelogram. And if I can't prove it to be a parallelogram, I cannot prove it to be a square. So the best I can say about this guy is that he's just a quadrilateral. This next one, I know that it's a parallelogram because all of my opposite sides are parallel. I know it's a rhombus because my diagonals are perpendicular. And I know that this thing is a rectangle because my angles are 90-degree angles. They're perpendicular. My sides are perpendicular. So I know that this guy is a square because he fulfills all three. This one, I know he's a parallelogram because my diagonals bisect each other. I know he's a rhombus because my diagonals are perpendicular. And I know he's a rectangle because my diagonals are congruent. So he is also a square. Down here, I know that this is a parallelogram because my diagonals bisect each other. I know he's a rhombus because he's a right angle, or because my diagonals are perpendicular. But I cannot prove this to be a rectangle. Nothing in this tells me this is a rectangle. So the best thing I can call this is a rhombus. That's the most specific name I can give it. This next one, I know we have a parallelogram because my opposite sides are congruent. I know I have a rhombus because all four sides are congruent and my diagonals are perpendicular. But I don't have anything to show me that this is a rectangle. So the best thing I can do is label this guy a rhombus. Here, I know I have a parallelogram because opposite sides are congruent. I know I have a rhombus because all four sides are congruent. And I know I have a rectangle because if this is 90 degrees, this is also 90 degrees, and this is also 90. They're all four corners are 90 degrees. So he's also a rectangle, so he is a square because he fulfills everything. We like him. This guy, I know opposite sides are congruent, so I know it's a parallelogram. All four sides are congruent, so I know he's a rhombus. My diagonals are congruent, so I know he's a rectangle. So because all three of those things are true, he is a square. All right, now we're going to do a proof, okay? And in order to do this proof, clearly I need to draw a picture because they didn't give me one. So I can get an idea of what we're looking at. I have A, B, C, D. And remember, we got to prove three things. I'm going to start off, I'm going to build my structure here in black with statement and reason. And let's look at what they give me. They give me AB parallel to CD, AD parallel to CB. Well, that proves I have a parallelogram. Then they say AC, that's the diagonal, is perpendicular to BD. Well, if they're perpendicular, that makes this a rhombus. And then we actually need to make a correction to this problem, guys. Scratch this out here for me and instead write AC congruent to BD. That tells me that my diagonals are congruent. If my diagonals are congruent, then I have a rectangle. So this is my structure. So let's start off by proving this thing's a parallelogram. That always comes first. So let's write out the first piece of the given. AB is parallel to CD, and AD is parallel to CB because it's given. And therefore I can say that ABCD is a parallelogram because my opposite sides, or I've got, let me rephrase that, I have two pairs of parallel opposite sides. Okay, we've proven we're a parallelogram. Now let's prove we're a rhombus. Well, AC is perpendicular to BD. That was given to me. Those are my diagonals, and therefore ABCD is a rhombus because my diagonals are perpendicular. All right, now let's take a look at proving this thing to be a rectangle. Well, they tell me that AC is congruent to BD. That's given. Those are the diagonals. When my diagonals are congruent, that makes ABCD a rectangle. because my diagonals are congruent. And then last but not least, I finally get to say that ABCD is a square, and that's just by the definition of a square. It's a square because it is a parallelogram, a rhombus, and a rectangle. All right, guys, go ahead and take a look at the MML. Thank you so much, and let me know if you have any questions.